Physics, part 67. We continue with the section question, and we have got the last question, question number 6. By accident, the door of a refrigerator is left open. Use the law of conservation of energy to explain whether the temperature of the room will rise, stay constant, or fall after the refrigerator has been working for a few hours. Well, the deformation of solids. At the end of our previous section, we should be able to appreciate the deformation is caused by the force that in one dimension, and the deformation can be tensile or compressive. Describe the behavior of springs in terms of load, extension, elastic limit, Hooke's law, and the spring constant force per unit extension. Distinguish between elastic and plastic deformation of a material. Deduce the strain energy and deformed material from the area under the force extension graph. Define and use the terms stress, strain, and the Young modules. Describe an experiment to determine the Young modules of a metal in the form of a wire. Demonstrate knowledge of the force extension graphs for typical ductile, brittle, and polymetric materials, including an understanding of ultimate tensile stress. When forces are applied to a solid body, its shape changes. The changes may be very small, but nevertheless the force affects the spacing of the atoms in the solid to a tiny external, and its external dimensions change. This change of the shape is called deformation. If you think of a metal cylinder, the application of force along the axis of the cylinder can either stretch it, make it longer, or squash it slightly, making it shorter. We call the deformation produced by these forces a tensile deformation for the stretching case, or compressing deformation for the squashing case. Hooke's law. A helical spring attached to a fixed point hangs vertically and has weights attached to its lower end, as shown in the figure. As the size of the weight is increased, the spring becomes longer. The increase in the length of the spring is called extension of the spring, and the weight attached to the spring is called load. If the load is increased greatly, the spring will permanently change its shape. However, for small loads, when the load is removed, the spring returns to its original length. The spring is said to have undergone an elastic change. In an elastic change, the body returns to its original shape and size when the load on it is removed. The figure shows the variation with load of extension of the spring. The section of the line from the origin to the point L is straight. In this region, the spring behaves elastically and returns to its original length when the load is removed. The point L is referred as the elastic limit. Beyond the point L, the spring is deformed permanently, and the change is said to be plastic. A loaded helical spring. Extension of a loaded spring in a graph. The fact that there is a straight line relationship between load and extension for the elastic change is expressed in Hooke's law. It should be appreciated that although we have used a spring as an illustration, the law applies to any object provided the elastic limit has not been exceeded. Hooke's law states that provided the elastic limit is not exceeded, the extension of a body is proportional to the applied load.